bed because my ankle is actually broken, and
Oh
I don't have
God.
my I don't have the prosthesis what it should like maintain my thing. So trying to not put it down.
Yikes. Right.
That is killing me that you get the basement behind you.
That's so funny. Jeez. All
Wait,
right.
the
So we are
basement.
officially live now.
What the
Let me go ahead
Hello.
and share the link with you guys so you can share it with
Yep.
other people. Um, and I'll throw
maybe I
this up
can.
Oh,
on
it's on
Twitter,
YouTube.
and then we'll get
Nice. I'm gonna
started in
send
a
it.
second.
Okay. Let me post it into announcement. Let everyone. We are live to talk about Barney's basement. Right now.
Welcome,
Send it
welcome.
to.
Oh, I see the logo behind you, Alex. Did you do that?
Jacob, my co-host, made that. Yeah, it's pretty clever.
Looks good.
Yeah,
Looks
yeah,
cool.
you see what's going on there. It's very
Yeah,
clever.
yeah, yeah. Really smart D. Oh,
All right, let's jump in. I think we've got a few people coming in now. Let me post this here. Okay, great. So,
Post to LinkedIn as well.
great. Okay, shall we get started?
oh my god.
All right. So we have our little theme music. Well, hello and welcome to the unofficial Unreal Engine podcast, where we talk about all things Unreal Engine and also Barney's Basement. This is a very special emergency episode because we are talking with the incredible folks from Sentient Art about an amazing Unreal Engine 5.3 project that they have released to the public called Barney's Basement. I am here now, live in Barney's Basement. I'm playing with chairs. I'm hanging out with flashlights. I'm looking at incredible lumen nanite geometry in a way that is very rare. And this feels honestly like something that Valve could have put together for like Half-Life Alyx. It has that level of detail and care and quality in it. There's tons of stuff going on with hand poses. There's all sorts of secret Easter eggs that I won't give away too much, but looking at you, Fridge. And I'm just really eager to have a little bit of a chat with Greg and Anthony, some of the creators of this fine project. I'll show very briefly what it looks like inside of the Unreal Engine sample scene, but for the most part, I want to stop sharing for a moment so we can see your faces and chat a bit. So hello, Anthony. Hello, Greg. How are you both today?
Hello. Pretty good. Thank you. Thank you for having us.
Yeah, this is really great. We touched base earlier this week. You guys had said that you wanted to, just have a little bit of help on a thing that you were working on, and I get a lot of requests for that kind of stuff, and I do try to accommodate them as much as I can, but bandwidth is limited, and so oftentimes I do unfortunately have to say no. But once you guys gave me a sense of what you were working on here, I was really thrilled to help out in any way I can, because it is very rare that first of all, that anyone is willing to give away an entire project to the Unreal Engine community. And a lot of times, if they are doing that, it's, it's a little half baked. There's something that they like, we're kind of trying out, and then they kind of gave up on it. And there's a bunch of broken code. But what you guys have here to me is a prime example of some really incredible props, art assets, examples of Lumen and Nanite, using Unreal Engine 5.3 in a way that is also very particular to the affordances of VR. So first of all, let me say thank you. And then I'll say, why don't you tell us a little bit about who you both are and how this project came about?
So I'm gonna start if that's okay, Greg.
Yeah. Go ahead.
Yeah,
No worries.
sweet. So I'm Anthony Carmona. I come from France. I started a company called Sentient Art about 5 years ago. Sentient Art is a company specialized in everything hard surface vehicles. We make art for AAA studios. We worked in the past with Epic Games. We worked with Tencent. We worked with Adobe. We made like tech demos for Adobe and such. And we've been thinking about doing our own stuff for a while now. And since, like the whole crisis happened with video games, we had a little bit more time. So I thought, why not try something new? I am a huge fan of Half-Life Alyx, and I thought that maybe we could try to redo something within Unreal that kind of looks like Alyx in terms of style, in terms of quality, and also in terms of VR experience. Like I was really curious to dive in deep and understand the systems that make Half-Life Alyx so immersive. So that's where we come from. Greg, if you want to go ahead.
Yeah, sure. I mean, so I'm Gregoire. I'm working right now with Anthony. Been working with him like for a year now. Been studying a bit the video game process, like a bit of coding and a bit of 3D. And after that, I just met Anthony. He gave me my chance, my first chance as a job, and I start a bit on 3D. Then he was like, "Oh, I wanna do some jam. I wanna do some project, like really fast project, tiny project, and something that we can give to the people." And he started push me forward on the VR stuff. And then we talk about Barney's, and this is how Barney started, basically. So I've been the developer, if we can say, because it's more like experience than the real development. Because as I said, I'm just a junior. This is my first project. So yeah, there it is, and we ship something that we really like, something that I'm really fan of. I'm really fan of the art. I'm really fan of the 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 project. That is super cool. I'm so happy to be there. Thank you so much, Alex.
Yeah, absolutely. And so let's dive a little bit more into how this particular project came about. There's obviously a lot of different things you could have decided to model. This basement looks so realistic. I wouldn't be surprised if this was actually a real basement. In fact, I was saying before we started recording that I saw what was behind Anthony, and I was like, "Oh, are you actually in Barney's basement right now? Is that what
Yeah.
it was all based on?"
Yeah. So talking about the art, so it's always been our specialty. I can maybe like give you the link to our station, so you can see what we do.
Yeah. Anyone who wants
I'm
to
gonna
share their screen at any
post
time,
it
go ahead.
there. Oh, okay. I can do that.
Yeah.
Sweet. Amazing. So let me do that. So we started. Okay, can you guys see now? Is
Yes.
it working?
That's
Okay,
great.
so we started doing vehicles for Twinmotion, so that's a branch of Epic now. We've done about 66 vehicles with them, and we have a lot of experience with vehicles, and we have a lot of experience with like spaceships and all that. We started like that, and then I was thinking maybe something that we need to do to push beyond just having the cool props is doing cinematic. So we started doing cinematic with the lobby. We spent a couple months working on cinematic, like recreation of a Star Wars race, like in the pod race in episode 1. And from there I was like, man, we need to do like a full scene. So we started thinking about what we could do, and the art was just trying to make something that would be done in production. That was the main goal here. So we spent a lot of time, just thinking about how we should take that on, and in terms of tech, in terms of workflow. By the way, I didn't say, but this is a team effort. This is like 9 people that worked on this project on and off, and some people were more regulars than others. So thank you to everyone who helped on this. And we made a ton of documentation about it and of how we want to take this on. We studied a lot of different games. The main source was Half-Life Alyx, because I wanted to have something similar to that. and we try to mimic as much of the art style in that game as possible, and just like push it further than what we had in the original game. Yeah, I could go into breakdowns of assets and such, but I don't think it's the scope here. We will have breakdowns in the coming weeks. I will be posting on our station and probably on LinkedIn as well. So if you guys want to give us a follow, you will be able to see much more of the thought process and how the scene was made internally, more than the actual finished product. I think that's very interesting as well for people who want to learn game development and how to make assets and such.
Yeah, there really are so many opportunities here for people to dive into any aspect of game design they want to. They can look at any individual asset in here and, you know, turn on nanite triangle mode as I have right now, or, you know, quads, and start to look at some different ways to explore the project. There's also, you know, a tremendous amount of thought and care put into the coding. And, you know, for example, if I click on, say, our swivel chair here, this has, you know, its own kind of physics constraint going on that helps with dampening. There's a bunch of other assets in here that are based on a grabbable mesh parent blueprint that is just a joy to look at, is like a wonderful template and foundation for how to have grabbable interactive objects that are using physics in a really meaningful way. So really, for anyone who is interested in Unreal Engine, game design, art in any way, this is such a treasure trove of exciting work to take a look at and start to experiment with. And so, you know, even just to explore a little bit of like what the lumen scene looks like, all these different kinds of view modes, how the reflections are being done. If we just go into like a pure reflection mode, I was going to say I could spend hours in this project. I have already spent hours in this project just over the course of the week, trying to see whatever little ways I could be of some help, but mostly just being in awe at all of the thought and care that was put into all the little levels of detail, you know, all the things on the workbench over here, just how everything is grabbable and movable. You guys want to talk briefly about what's going on with the hands and why we can see these hands in different poses in different places?
I mean, Greg, you're the master of this. You talk about it.
Okay. So the thing with those is, like, as Anthony said, is a huge fan of Half-Life Alyx, and he came to me saying, like, okay, I want to do a VR project, which is as much as we can do good as Alyx. So I was like, man, I'm alone. It's my first project. Please please be gentle with me. And then I just like throw myself in this project. And he said to me, okay, that I wanna do something that is really easy for the designers to use, like create a system that we can just drag and drop the static mesh, and you can by yourself just moving the hands in the static mesh in the blueprint. So you can move the hands, create something with the control rig, because we control rig the right hand. The other one is just a mirror stuff, so we can explain this like
Yeah, I
the
can show
tech
you
part
after if you want.
Yeah, and so I dive into it, and the thing is, you can actually like select the animation you want to play when you grab the thing, and also you have few types of grabbing stuff. Like you can grab it full procedurally or grab it full snapping. Then how it doesn't matter how you take the object, it will play the hand animation preview, and that's it. It's more like how's it called, like UX designer friendly stuff. Like you can the blueprint is a bit complex. It's a kind of huge thing, but you can do a lot of things with it. Like it's really easy to set up,
Yeah,
actually.
so the whole philosophy was to have one blueprint that rules them all, instead of having like different small parts. It comes with a few issues. We have a bug. We don't know why the physics doesn't sleep, but otherwise, it's really great. You can just like drag your thing, you put your mesh in it, and that's it. It works. It's freaking amazing. I can actually show you if you'd like how to set it up. It's super easy. It takes like a couple minutes.
Please
By the
do.
way, but by the way, I'm just stopping you, Anthony, because we're gonna write down a whole documentation on how to use it, and also creating some videos, like a really simple one. We will do this in the few days, I think, after the GDC. But we will do it like the good process to do it, and we also want to push it again because there is a bunch of stuff that we want to do it again. That we wanna as I call like we want to make it better. Please forgive my English. I'm a bit I'm a bit tired right now.
You've been through a lot,
Yeah.
Greg. It's okay.
Thank you.
So yeah, Greg actually broke his foot a week ago, and now he's traveled to San Francisco for
San
GDC.
Francisco.
So the travel has been rough, apparently.
And the plane was like delayed for 6 hours. So I've been in Munich for 6 hours just waiting in front of my chair without any possibilities of moving out. I was like, oh my god.
That's brutal.
Yeah.
Jeez.
All
Well,
right,
going
you
back
put my
really
headset.
briefly to the mention of, oh, the physics aren't quite sleeping the way we expect. There's a lot of, in the same vein of which I've been trying to add my little 2 cents to the project over the course of this week. I hope that this does become very much a community effort where we do see other people chiming in and saying, oh, have you guys thought about doing this or this or this, or even just, forking the GitHub entirely and seeing people to continue to use this. It's such a tremendous foundation for so many different kinds of projects people might want to do. So to be clear, Anthony, do you want to give a little demo, or are we going to hold on?
Yeah. I was just starting the headset.
Yeah.
Just so you know, the GitHub is totally public, so you can download the whole project. You can play around with it. You can modify it. It's a MIT license on all the assets and all the code. So you do whatever you want with it. If you want to put it into your own little game, you can put it there. If you want to do a different experience from the code, you can do it as well. If it's a commercial venture or commercial product that you wanna do, you can use it as well. Our goal is more to get our name out there, like having people know about us over the next few months and years, thanks to this, rather than nickel and diming everything. I think tech and art are really fun, and moments like the video game crisis that we are living at the moment are great opportunities to just try new things and try to create a sense of community with people. So that's mainly the main angle that we had on this. All right, let me try to start my VR preview. Okay, it works. I'm going to stop it now because it's too much. And I'm going to share my screen again so I can make a sweet small demo.
Let's do it.
All right, can you see my viewport right now? All right, sweet. So if you want to create a grabbable mesh, it's super easy. You just take a model. I mean, you just create a new, let's do it here. I'm going to create a test folder. Okay. And you create a new blueprint and you call grabbable mesh. You have BP grabbable mesh here. You click on it, select it, and you give it a name. So that will be my BP grabbable object. When you enter the blueprint, here you will have all sorts of things. You will have a origin model. You will have a static mesh that you need to replace, a grab component, your left hand, right hand control constraint, and physics constraint. That's for, if you want to link objects together, like for instance, like you have a swivel chair or you have a door or anything, you can control it with this. So let's replace our mesh. I'm going to replace my Nomen with, let's do, what can I take as a mesh? Let's do a mallet like this. Okay, we have a mallet now. So if I just compile this and I place it into my world, I will have my mallet. I'm just gonna check if it works in simulate. Okay, it does work. So now I'm going to switch to VR preview, and I'm gonna have to switch the window. New share. All right, can you see my window now?
Yeah.
I think you can.
Yeah.
Sure. Okay, sweet. So now you can just go ahead, move around to it, and you will be able to grab procedurally. So it's not perfect, of course, because it's procedural, but you will be able to grab stuff. The way the hands work, they detect the collision of the object, and they will try to stop moving the fingers to the collision. So it's doing like small ray casts. Ray casts to determine where the position of the mesh is. So that's the first configuration, and then we can actually go a little bit further. I'm going to switch back to the other screen. Where is it? Here. Meet my window, please. Okay, there we go. All right. Can you see now? Is it working? You see the viewport?
I think so.
Yeah.
Okay.
Yeah, it is working.
All right, so we can switch the mode from into our BP grabbable object. We can switch from conditional snap, from full free to conditional snap. And if we do, where is it? Hand visibility, we will be able to see our hands. So we see here our hands. So we have like two hands, left and right. And you can change the pose of these hands by you can actually make like custom hands yourself, like custom hands position. I'm going to show you how to do that. There's a super easy way of doing it. Let's say I'm going to just hide these hands. Okay. All right. Well, let's create new hands. So I'm going to go and look for my control rig, CTR. It's gloved hand. And we are going to take my gloved hand right. And now I'm spawning a hand directly into the viewport. And I can move my hand like so. I turn it around. Okay, and I place it. And then I take my control rig like so. And I just have to close my hand around the object. Easy as that. Let's do like a thumbs up at the same time. Like so. All right. So now we have our hand with a thumbs up. I'm going to key all of this, reduce that timeline to 1. Okay. And I'm going to right click here and press, I don't know if you can see when I right click, but I'm going to say it. You right click the skin mesh and you press bake animation sequence and you just give it a name. So I'm going to give it a name AS thumbs up. All right. What, did I forget something?
No, I think it's already existing because of the
No, it's good. It's good.
Okay.
It's good. Yeah. So now that my pose is done, I can actually delete that. So I'm gonna close my sequencer, and I'm gonna delete my hand. I don't need it anymore. And here in my grabbable mesh, I'm going to look for my animation, and I'm gonna call thumbs up. Thumbs up. And same thing here. And I'm gonna show the hand visibility, and you can see that now I have my hands with the thumbs up. So I can just place it the way I want. So I'm gonna place it here, and I'm gonna take the other one and place it here. All right, turn it around because who holds a mallet like that? I have no idea, but it's a weird guy. So I'm gonna just move it and place my hands exactly where I want it. All right, so now this is done. I can compile, and then I can switch my grip point. So the grip point is the point at which your hand will snap into position. So I can increase the size of this to something like 10. And so when the hand is going to get into that range, it's going to automatically snap to that point. So I'm going to save that, and I'm going to run it now, and it should work. It should work. It's possible that it doesn't work because
by the way,
demos.
by the way, you have to be careful with the grip point. It's not about the size himself. Like if you increase the scale, it won't work. You have to play with the diameter actually, like the what's it called? Um, yeah, it is the diameter.
Yep, working.
Like
Doing good.
the
My fingers are messed up, but it works.
Lovely.
So if you hit the grip point, it will, in condition snap mode, it will grip at the point you want it, and you preview on the BP. But if you don't, it will just be in procedurally mode.
Yeah. So we're using the exact same system, for instance, for these doors. So you can see that we are using a custom animation here,
Mhm.
and then we just use physics control to say, hey, I want to open or close this door, and we have the same thing for points like here. Like custom animation, it uses two fingers and it opens the tray.
So
And
cool.
then you have this for the button. You can turn it around like that.
Yeah.
So yeah, at the end of the day, the goal is to make it fairly natural. When you're grabbing stuff, it feels natural. That's very important to us. We also have like implemented a torch where you can turn on and just
We
play
call it
around
a flashlight in
with lumen.
America.
Oh, sorry. Yeah, flashlight where you can play around with lumen features. It's pretty cool. You can do everything real time. It's pretty cool.
Yeah. So to be clear, how much of the lighting is baked, guys?
Zero.
No one.
We baked zero.
Yeah, that's nuts. And just to give people a sense of, because I've honestly never tried to even have this many lumen lights in a scene before. I've just pulled up the light mixer, which for those who don't know, Windows light mixer, and like look at all the lights inside the scene here. And a few of them are set to stationary. We could set those to Bavul as well. But yeah, they're all casting shadows and they're all active. And yeah, I would never tell anyone to do that. And yet somehow this is all working very well. And you have pretty minimal GI noise as well. I think some of that has to do with the fact that you're not using a lot of emissive materials, and that tends to really crank up the GI noise. But it all just looks really good.
Yeah, we're being careful. So we had the chance to have a friend of mine. His name is Samuel Fradet. Shout out to him. He's the lighting lead at Gearbox, who's been helping us with the lighting. And man, it makes such a difference to have someone who knows this stuff to make art, especially for this. It's crazy.
Yeah.
It
I want to get to a
makes
couple of the questions in the chat, if that's okay,
Yep.
because we got some big fans who are giving you guys some nice compliments. We have someone like we have Wiktor, Wiktor, saying awesome quality with a big oh face, and we have the great Alistair Hume, who makes wonderful Unreal Engine videos, saying this looks fantastic. Glad to see Nanite working in VR, and he wants to know what aliasing approach the team took for this.
So we ditched TSR because TSR was causing issues on the left eye, if I remember correctly. I had like weird flickering on the left eye, so I switched it to TAA, if I remember correctly. I've read the documentation, the Unreal documentation a while back, and it recommended that for VR we should use TAA. So I just did it. I'm dumb like that sometimes. I just read
but,
it.
And also, I just want to point out to everyone that we're not in the forward rendering path. If we were, MSAA would be the recommended anti-aliasing method. MSAA doesn't even work with deferred. You need to be in deferred in order for Lumen and Nanite and any kind of ray tracing to work.
Yeah, one of the first questions that we had when we actually started the project was, are we baking or not? And are we using forward rendering instead of deferred? Because there's a lot of caveats of using deferred and non-baked solutions, as much as there are caveats of using forward and baked. But we went all in, and we were like, I think we can make it work. We are barely reaching 40 FPS, but it works.
Yeah. And Alistair wants you to know that you can get some extra sharpness out of it if you play around with some of the CVARs around frame weighting. Interesting. I don't know about that much either. You guys also ended up implementing DLSS as well.
Yes.
I do want to make sure everyone knows that you cannot make DLSS work if you have TSR enabled as your anti-aliasing method, because they will fight each other. DLSS will work with TAA though.
Yeah.
That is correct. Any other stuff that you would like to see? I mean, I can show you the optimization made on the lighting, some of the stuff we've done with virtual textures.
Yes, let's definitely do that. Let's do a couple more questions real quick. Let's wrap up Alistair's thought by saying he wants us to know that his personal favorite anti-aliasing method right now is AMD's FSR, which is interesting because I played with it. I have not had as good results personally with DLSS, but because I respect Alistair a lot, I'm going to certainly try it out more myself now. I do know the nice thing about AMD's FSR is it doesn't require specifically an RTX card. Of course, it's an AMD product, whereas DLSS is not going to work on an AMD card. So it's more helpful for, general population, everyone. Also, really quick question from Leonhardt, who wants to know if you guys are planning on putting this on the marketplace. Why is it just a GitHub link right now? What's the process like for making this accessible to the community?
So that's very interesting.
That's the main point. That's the main point.
I have a bit of a story about that. So we tried to put it on the marketplace. The issue is that you cannot put anything on the marketplace for free. Free content is only by invitation. So we actually pushed around a little, and I got a contact now who's going to make sure that our product is free on the marketplace. Thanks to him. Thank you, Martin. That's very nice of you. And yeah, right now we are trying to pass the technical review by Epic. There's probably going to be some back and forth with them, but as soon as it's approved, we will be able to put it out there.
That's great.
Yeah, we also tried.
So funny.
Yeah,
I mean, I bet a lot of people didn't know that you can't just release free content on the marketplace.
I did it 2 days ago. we worked something like 9 months to make this release come true, and 2 days before we release it, we discovered that we cannot actually put it out for free. I was so mad. It's that's life, I guess.
Yeah.
We also are trying to put it out on Gumroad. We are trying to put it out on itch.io. Same thing with itch. It cannot receive files that are bigger than 2 gigabytes, so we will have to contact them and ask them for more space. It's a pain overall, but for now you can have the GitHub and you can have the sketchy Google Drive links if you want. That's all I can give you for now.
Yeah, I'm not complaining at all. And by the way, I do want to point out or ask very directly if anyone is as blown away by this as I am and is like, oh my God, thank you guys so much. How can I thank you? Can I leave you a tip? Can I buy you a coffee? Like, what's a way that someone could express their gratitude to you?
Yeah, go ahead, Greg. Go ahead.
I got an idea. If someone is coming at the GDC, we would like to get a beer together at the GDC. Yeah. I'm a bit sad that Alex is not coming, but anyone who's coming to the GDC, it will be a pleasure to meet you and take a beer talking about Unreal and stuff. It would be a real pleasure for us.
Yeah, we're not done with the interview, and it sounds like I'm about to say we are, but where can people find you if they want to reach out?
So you can find us on our website, sentient-art.xyz. I'm gonna put it into the chat so you can have it. Great. There's also our art station. If you like art, I know that it's probably more of a technical community here. So we also have our Twitter. I'm putting them in the chat. I don't know if it works, but it's there.
Yeah, and all those links are also in the GitHub link as
Yeah.
well, which I've also put into the description of this video. And
Yes.
trying to keep up with the chat. But cool. All right, Anthony, let's talk a little bit about virtual textures.
Sure thing. So virtual texture, for those who don't know, is a pretty cool system. I think it was first implemented, not in its current state, into a game called Rage by id Software. They would call it Mega Texture at the time. It was like a huge atlas of textures, and you would have a pointer that would go from one texture to the other and would load the texture dynamically. So it's I'm not a rendering engineer or anything like that, but from what I understand, it's a very cool way of loading and unloading texture at runtime and making sure that your game, even though it's using a lot of texture, doesn't kill your GPU buffer. So they implemented virtual texture. Virtual texture is a little bit different in the way that it has the coordinates of the texture directly onto the hard disk. So when you load your level, you can just point directly to that texture coordinate, and it would load at runtime. So it's kind of the same thing, but a different way to achieve it. And virtual texture allows us to have a ton of objects and a lot of texture in that scene, and without killing our GPU, which is pretty nice. So if I'm gonna share again, let me share my screen. Yes. Okay. So if we look at the meshes that we have here, is it working on your end with
Yep.
Yeah, okay, cool. So if we look at meshes here and we go into the material tab and then textures, you can see that you have that VT symbol. So that signifies that this is a virtual texture, and our shader is made in such a way that it's using virtual texture for pretty much everything. So you can see here, the type of texture is a virtual mask, and here it's a virtual mask as well. And then you have like virtual normal map and virtual color somewhere. I don't know where it is, but there's virtual color, trust me. The way this works is you're going to see sometimes texture popping, especially in the build. I don't know why it's so slow, but you will see texture popping, especially on something like grounds and stuff. But overall, it will allow you to have a lot of textures displayed. I think we have something like uh, about like 1.5 gig of texture within the engine at the moment. Wow. And it can safely run it within the viewport or within the build. You can see if I do a stat RHI, you can see that right now I'm using 2.9 gigabytes of UAV texture, which is the virtual textures. And if you move around, you will see it unload and load at runtime, which is fairly interesting. The other advantage of this is that since it's virtual, you can link textures together as one big texture. So if I open up the truck here, you have 4 textures that are chained together. So you only need to do one material, and you have these four sub-materials being linked together automatically. So as you know, it is a good technical investment, and it's also very nice for your artists when they want to make assets, because within Substance Painter, they can paint across the different, what's it's called, UDIMs. You can paint across the different UDIMs, and you can just load it in as it is, and it will work directly on your whole mesh. It's pretty nice and pretty convenient. So if you have a scene that either uses a lot of textures, or if you have a open world, I would really recommend you to use virtual texturing. The old stream texture technique is kind of almost deprecated now.
Yeah. Do you think you could demonstrate briefly how to set that up?
The virtual textures?
Yeah, like if you were going to try to do sub textures and kind of combine smaller textures together.
So it's fairly simple. I'm gonna duplicate that. I'm gonna move it here, and basically when you're gonna load a texture that is not a virtual texture, it's gonna be a regular texture. So it's gonna be like this. You don't have the VT logo here.
Mm-hmm.
So you just select your texture, right click, and you go to, I'm sorry if you don't see the menu, but you go to convert to virtual texture. You get a menu, you press OK, and it turns it into a virtual texture.
Mm-hmm.
Just be careful. Once you have virtual textures, you cannot use virtual textures into regular non-virtual texture shaders. So you need to specify in your texture sampler that you will be using virtual textures. That's the only thing that you need to do.
Right. And then so how does this make its way into a material, just so we can see that?
You mean, sorry.
Well, I want to make sure that we're demonstrating how you end up taking advantage of lots of textures, reducing draw calls. This whole project has like 800 draw calls in it, which seems ridiculous.
So if let's take the truck for instance.
Yeah.
We have the textures here. You can see that I have my low BC is my truck body. I didn't rename it. I'm a bad boy. I'm gonna have to change that. They're gonna flag it.
Oh.
Epic is gonna flag it. I know for sure. So if I take that texture here, it's as simple as just going into the material here and just putting the texture in, and that's it. It just works.
And will that work with the same kind of slot that will accept regular textures, or it's a particular like texture slot for virtual textures?
Yeah, so you need to change that. So on the some trash. Okay, good. M underscore, I'm gonna call it VT truck. So that's a master material. Be careful with master materials. Rather use material instances. It's better for the engine because it reduces the number of calls. And
one material to rule them all, kind of like we were talking about.
Exactly. Exactly. So we do a low BC, we take that, we put it into here, and that's it. That's you can see that's already virtual color. So now I just need to link it like so, and you're done.
Yeah. So a very similar workflow to if you weren't using virtual textures.
Very similar. Yeah. It's just more convenient in a way.
Cool.
The only caveat of this technique is if you don't have a SSD, you're going to see a lot of texture popping. So they still have this technique for all the hardware or for the Nintendo Switch because it doesn't have a lot of bandwidth. So that's why we don't do VT everywhere.
Yeah, and I believe virtual textures are supported for mobile things like Nintendo Switch and Android and standalone VR. But yeah, you do have to be careful with them, especially if you have limited RAM.
Yep.
Cool. I want to draw a little bit of attention to the audio in the project because good audio makes such a difference for feeling immersed. There's like a room tone thing going on. There's all sorts of different sound effects with how you activate everything. I know you guys had a particular sound designer who wasn't here, but you want to talk a little bit about that process?
So I cannot talk too much about audio because it's our audio friend Adrien who's doing it. I know that he's using Fmod and he's been working at it. Actually, it's still a work in progress, so there should be an update to the GitHub with more sounds and actually more sound that fit the scene. That will probably happen in the next few months. So yeah, I don't have much to say, but what I can say is before sound and after sound is completely different. Like if you don't have sound in your scene, your brain won't register the assets the same way as when you got sound in the scene. It's crazy. It's like what they say about what's it called? Supply chain. When supply chain works, nobody notices, but as soon as it fails, everybody knows. It is exactly the same thing with sound. If you don't have sound, you don't notice. But as soon as you have sound, you notice that you didn't have sound before, and it's amazing once you have it.
100%.
So yeah.
Yeah. Cool. Yeah, go ahead.
Oh, I'm sorry. I would like to take this a bit of moment, like because we say a lot of thank you from the beginning of the interview for a lot of people, and I would like to say a big, big, big thank you to the Midgard team, which is the studio next to us. Because while I was developing the thing, I was, I mean, 50% of my time I've been up just walking to them, asking some questions, and I would like to say a big, big, big heart on you guys, because without you, this amazing thing shouldn't be possible. So big thanks for everybody who just helped me help the project, and yeah, just big heart on you.
Yeah, that's great. There's a clarification question in the chat about draw calls, so maybe we can just go back to that for a moment.
Yep.
So for anyone who doesn't deal with draw calls a lot, typically in a game, every draw call is going to be every new material of any kind. And if it's one object, one mesh, and there's two materials on it, that's two draw calls. If you have that object, if you have two of those objects, suddenly you have four draw calls. And you can deal with instancing in some of these, more standard methods for reducing draw calls. But when we were talking about a master material versus an instanced material, that doesn't affect draw calls. That's more just about, general shader complexity and overhead. But yes, whether it's an instanced material or a master material, that will be its own draw call. But anything, Anthony, Greg, you guys want to say in general about how you guys got the draw calls down to be so low in this project?
Yeah. So we actually we actually so sorry, the way Unreal does its stuff is not very transparent, let's say. When it does
I know there's a bit of a pun there.
Yeah, when it does batching, when it does static instancing and stuff like that, we don't really know. So what we did is we just followed the best practices set up by Epic in their documentation. So that is using a lot of instances as much as we could. So as soon as we have the same type of material, so that's like if we have like a lit material or a transparent material, we use the exact same master material with a instance on it. So we don't have tons of types of materials. To reduce the draw call count, we also use Nanite a lot. I found out that Nanite does reduce the draw calls. I'm not sure how and why, because I'm just an artist.
It's just magic. Yeah.
It's just magic. It's so good. And that reduced the draw call quite a bit. So basically, I think that the way Nanite works is just it takes some kind of occlusion culling and says, oh yeah, this goes away, I don't need to treat it, or this is too small, I just don't display it. So it is very optimized right now. In my viewport, I'm at scalability high in full screen mode within the editor. If I do a stat unit and I do a stat FPS, I get between 100 and 120 FPS on the scene on a 1440p monitor. And I'm running 127,000 triangles and about 700 draw calls. So it's pretty good.
That's very good. Yeah, don't sell yourself short. That's excellent.
I'm pretty happy with that.
That's great.
And then in terms of complexity for the shaders, we try to keep it as low as possible with very, very simple shaders. So everything that is static and not transparent is in the green. So my fragment shader, pixel shader, is very low in terms of complexity. Of course, it will become more complex the more lights you've got on it. So you need to be careful with the number of lights. And also I found out that
sorry, Anthony, just to clarify. So I don't think lights will show up though in the shader complexity. If we do lighting complexity, then we'll see where things get more complicated. There we go.
That's lighting complexity. So The thing is, your pixel shader, or a fragment shader, depending on how you want to call it, um, gets more complex with the more light overlap you got because it takes more time for the GPU to render them. So you try as much as you can to have as little light overlap as you can. The work that Samuel did on this is quite fantastic because we don't have that much overlap, except in the areas that I touched. That I think that's bad here, but the rest is actually pretty good. So yeah, you have to be careful when using Lumen and Nanite. Mostly about this. You are careful with your shader complexity, not trying to have too much complexity in there, and then you are careful with your light complexity. And as soon as you have these two figured out, your performance should be pretty good. You know, as much as Lumen allows you to be good, but it should be pretty good. Yeah. Another thing as well, when you use Nanite, try not to have objects that are not Nanite. Like it's very important to have as little non-Nanite objects as possible because the shadow complexity will be derived from the fallback mesh that Nanite creates. So if you don't have any Nanite object in your scene, your shadow complexity will be super high. So yeah, try to have as much Nanite as possible in the scene if you're using Nanite.
Yeah, I think there was a bit of a miscommunication, I don't want to say it like that, from Epic early on, where it sounded like you should only use Nanite in a situation where it's a very high poly object, kind of how you would use, LODs in a typical scenario. So I think at first a lot of us thought that like there's no reason to turn on Nanite if it's a 5,000 polygon object, but it does seem like for Nanite and Lumen to work best, there's as much of that going on as possible. Same thing with virtual shadow maps, and every time there's something that's not Nanite or whatever, using shadows in a different way or using light in a different way, it stacks up complexity in a way that I kind of liken to like a hybrid vehicle versus an electric vehicle, where an electric vehicle can be much simpler because it's using like a very reduced set of systems, versus a hybrid vehicle needs to deal with all the things an electric car can do and all the things a gas car can do, and that adds a lot of additional complexity.
Absolutely. Also, I think this demo is a pretty good example of being able to use optimized assets within Unreal with Nanite. I haven't seen that many demos that do that, unfortunately. Everything here is baked, and everything here is optimized to a point. So if I don't know if the compression will allow to see it, but if you look at the wireframe of the scene, there's not that many triangles, and Nanite still holds up pretty well. So I think the best practice Nanite for Nanite and Unreal in general with the 5.0 and up is to still do as much optimization as you can on your meshes. Nothing will replace good thinking when you're making assets than this. Your performance will be better, and your hard drive will thank you. Because if you have like this chair, for instance, I could be like, oh yeah, this is Nanite. I'm just gonna put like my sculpt or anything in there, and my chair is gonna be a million triangles. My hard drive, the space that it will take on my hard drive would be crazy. Whereas here, it's like it's not even a megabyte, the file in itself. So it's like a lot less things that needs to be loaded on runtime, and that's good. It's everything has to be optimized, and I think it's just good practice when you make games.
Yeah. I think people sometimes underestimate the power of good material design as well. Like an excellent material on a low poly object can look amazing, whereas a very bad material with horrible tiling on a super high poly object is still going to look pretty bad.
Yeah. And
that's the big debate between Anthony and I, because it is for like, okay, I mean, modeling for everyone is something like but most of the people misfortune is about the texture, because a lot of people do really nice modeling now, Like it is like a normal thing, but like what is gonna make the difference is more about the texture.
Yeah.
Like understanding the texture, understanding how the light is gonna bounce on it, and how you're gonna light the object by himself is gonna make a huge difference. Even if it's even if it's the model is not that complex. I mean, look at this share. This share is pretty simple in terms of modeling, but in terms of texture, this is amazing, and this is
Yeah.
why it looks so good.
And
Yeah.
same thing with environment textures. It is very
Yeah.
important to, we don't rely too much on decals. We don't have that many decals in the scene because most of the texture hold up by themselves. We spend a lot of time working on those to make sure that they look good. So for instance, if I open the concrete wall, I'm going to look at the texture itself. Yeah, you could look at the texture. You can see that you have
Oh my god.
grime at the bottom. You got like some color variant and all that. That's very important to us to have as much information directly into the texture. That's a bit of a an old technique dating back to Quake 2, actually. They would use something called man, I'm forgetting the
The
word now.
hotspot
Hotspot
texturing.
texturing. So where they would detect the size of the wall, and they have like these kind of trims here. So they cut the texture into different parts, and they would line the edge of the texture with the edge of the wall, so that you would get a pretty decent angle like that. I don't see anything because it's dark. But yeah, that's how they did things at the time, and I think it's still a very good technique. So if you do like textures with a lot of information, that doesn't repeat too much. You don't see too much of the title, and you have smart ways of modeling your stuff. You can get with a lot of things. Same thing with this wall, for instance. Here we have only two textures. We have this side. We only have like a brick wall, and we have a paint. So you can see the texture for the brick wall. It's this one that we made within the Substance Designer, and we have we have a blend for the paint, and you can just like vertex paint that, and that's it. It's that easy, but it reads well. That's what matters when you're making games and environments.
Did all of the texture atlasing happen over in Substance Designer or Substance Painter, or did any of that happen
Yes.
over here in Unreal?
So we did the blending within Unreal with the painting tool. But most of all the offering of the texture was done inside of Substance Designer.
Yeah.
If I show you, for instance, I need to turn off Nanite to be able to paint my paint. I'm gonna take this wall here. I'm just gonna turn it off. Yeah, because Nanite doesn't allow you to paint vertex painting, unfortunately. So you can turn off Nanite, and then you can start painting. So I'm gonna remove that wall here. And I'm going to go into my painting tools. There you go. And you can just, add or remove the paint by yourself. And once you're done with that and you're happy with the result, you can just apply. You click apply here, and it'll overwrite your mesh with the info of the vertex painting directly into it. And then you can just put it back in Nanite and it works. That's how we did most of our stuff here. Same thing with the floor. The floor is exactly the same. It's a mesh with a texture that you can paint, and we can do like all sorts of effects with that. For instance, if I turn Nanite off, same thing, and I do my painting, you can see that I will have like either a clean slab, or I will have a dirty one.
That's great.
And once I'm done, I can just apply it, overwrite, and just turn it back to Nanite, and I'm done.
Yeah, I didn't know that. I didn't know that you could do that, because I knew painting was unsupported with Nanite, but I'd never thought about, turning off Nanite, doing the painting, then turning Nanite back on. That's a great workaround. Some of the textures, I'm just kind of looking at all the textures in the scene now, are significantly large. We have the fridge texture that's 20K by 4K, a lot of 8K by 4K, some 15K by 2K. How did you guys decide what resolutions to end up at?
That's a good question. So usually when we work in a production environment, we have what we call a TD, so a texel density. And that's the size of your texture relative to the size of your object. So for this project, we try to have a texel density of 10.24 pixel per centimeter. So if you have 1 centimeter of your object, 1024 pixel, you will have 10.24 pixels within that centimeter. So that sounds like a lot, but it's not that much. And so we just by abiding to that rule, we determine the size of our objects. So if you take, for instance, let me go back to, if you take, for instance, something like our pens here, these pens will be a pretty low texture size. Unless I forgot about them. Yeah, they're imported at 2K, but they will be displayed as 512. And they will still hold up. And same thing, because the fridge is pretty big, it has a lot of, it's very imposing, and we want the resolution to still look good when you look at from up close. Because it's VR, we don't have the choice, unfortunately. We have to make it look good. We have made extensive UDIMs for it, and so we have like different textures in it. So if I take my texture here, you can see that I have 1, 2, 3, 4, 5 different texture sheets that are together. So that's 20, 48, 4080. So that's 20,480 by 4K. And my max in-game resolution will be that size. But if I were a bit smart, I would have downscaled it by 1. So I will just show you how to do that. You can just press load bias and do load bias by 1, and that will reduce the size of your texture.
Yeah, and then of course we can also use device profiles to make it per device, like what the max texture is going to be. And then we also have an option in there for maximum resolution. And then rather than using LOD bias, it's, you can very clearly specify, like, don't let this get larger than 8K or whatever. But, it's certainly nice to have the highest quality possible textures in the actual project.
So what we try to do as much as possible with this project is to have the largest textures allowed on the project. Usually we try to go for 2K with props and 4K for everything that is bigger. But sometimes we run into issues where Git would not let us upload the texture because it would be more than 100 megabytes. So we would have to use LFS.
Right.
And LFS is paid, and it costs a ton of money. Yeah. So we decided to go with the lower resolution texture for some of them.
That makes sense. Probably wrap up in a little bit. A couple more things I want to touch on. I noticed in the project settings that we have support hardware ray tracing unchecked. So everything here is software ray tracing. Is that primarily just to help with frame rate? I'm just curious if that was an intentional choice.
So it was a bit of a issue that we had. Sometimes when you have hardware ray tracing on, you have like black dots on your meshes.
Yeah,
like you have like weird splashes on your mesh, because the lighting that Lumen does kind of bugs out with the how is it called, the fallback mesh.
The proxy mesh,
yeah, the proxy mesh, and you end up with issues. So I decided to go against that. So by just turning it off, because hardware ray tracing is pretty cool, but we're doing VR, so we don't really need it. And it would take a lot of performance anyway. And when it was on and not used in the scene, we would actually see it in the profiler. So I decided, to just turn it off completely, so we don't have it in the render queue.
I'll give a quick hack for anyone who runs into this. If I can share my screen real quick.
Yep, go ahead.
Just if anyone is in a situation where they're like, oh man, I do want to allow for hardware ray tracing, but weird black splotches are happening, which definitely does happen. You can, on a case-by-case basis, open up the mesh and actually uncheck support ray tracing, and then it will solve that. But it's definitely, a hack and not the not the ideal way to go about that.
Yeah,
just a
you
fun
you
fact.
can actually reduce those kind of glitches by increasing the resolution of your fallback mesh. But first, it won't be perfect, and second, it will increase the complexity of your fallback mesh. So that means that in turn, your lighting will be more complex. So it's a bit of a, you have to balance the two.
Yeah, I hear you. Well, great. Anything else that anyone would like to talk about before we say goodbye and head off into the weekend and GDC and all those fun things?
Questions or anything?
Let me give you guys a little bit more love from the chat. We have, thank you so much for the scene. We have, this is beautiful. We have, I'm so grateful for this project. Yeah, all good stuff. So well done, everyone.
Well, thanks.
Let me
Thanks a lot.
Put the link of the GitHub again in the chat. I know that Phil La was asking for it.
Yeah, it's in the
it's in the description.
It's in the description. I'll put it in the chat one more time just for everyone there. Real quick. So Thomas wants to know if it's possible to bake virtual textures, runtime virtual textures. I have no idea.
RVTs?
RVTs, yeah.
Oh, yes, RVTs. Oh, so you can't bake them per se, but the way it works, it's more like a shader cache. So when you have RVTs, it's because okay, I'm gonna go a little bit on the I'm gonna put my teacher hat here.
Do it.
When you do terrain, especially terrain is the worst case scenario for a shader, because terrain uses a lot of textures and you have it in your face all the time. It's very large, uses a lot of textures, and you have it in your face all the time. That's the worst case scenario for it, for a shader. So since you have all that, your shader complexity will be super high, and you will end up with something that lags, and it's not cool. So what they came up with is RVTs, so real-time virtual texture, and basically it's a shader cache. So what it does is, in your shader, you can tell it, hey, I want this to be baked down into a simple texture. So with the setup of RVT, it will turn a very complex shader into a static shader that will be saved directly onto your GPU. So it's pretty much like if you go into Photoshop and you have all your layers and you just do like you flatten the whole thing into one texture. That's what it does basically. It's very cool, and a lot of people on YouTube and all that, they say, oh, RVT are amazing because it does blending between objects and your terrain. It's not that. That's the performance that you gain from using RVTs that is actually amazing. I mean, the blending is really cool, but the performance gain is insane. You would go from having something that barely runs to having a very, very simple shader into your terrain. And it looks okay. It looks, sometimes it can be a little bit pixelated depending on the resolution you get, but the performance is so much better.
Yeah.
So yeah, if you are looking for information about RVTs and SVTs, I would recommend you to watch the video by Epic. Let me send it to you. Real virtual textures Unreal. I found out that most people on YouTube talk about the cool looking aspect of virtual textures, but nobody talks about the technique behind it, except for Epic. It's a 2-hour talk, but it's really, really good. So yeah, take the time, just like grab yourself a drink or something and watch it. You will end up learning a ton of really cool stuff.
Where's that
Uh, I
link,
put
Anthony?
I put it into the chat. I don't know if I'm shadow banned from doing it or not.
Oh no, I
So
hope you're not shadow banned. Throw it in the Zoom chat. Yeah, I'll put
yeah,
it in there. Geez, don't be shadow banned. There's Anthony's link into the chat there.
there
Great.
you go.
Well, what a fun discussion, guys. This has been great. And I'm sure everyone who's currently downloading and exploring your wonderful project is going to have more questions for you. Everyone, again, you can find more information about Anthony and Greg's company, Sentient Art, inside the actual description of the GitHub project. Download it, run it, play with the settings in here. If your computer isn't running an RTX 4090, try pressing the 0 key on your keyboard to cycle through some different quality settings and keep playing with it. And if you come up with some good ideas for how to make this project even cooler than it already is, then, fork it,
Please
share
do.
CBARs, whatever might help give back to the community.
I dare you, make something cool with it.
Yeah, I mean, if someone actually releases a game and can point directly to this project as an important precedent, like that'd be amazing. Let us all know.
Yes. I've given my contact email. If you want to talk to me, you can always send me a message. I'll be happy to to help or guide you in any way. For now, the project doesn't have any documentation, but we will do documentation over time. We've been super busy with just wrapping up this project, but documentation will come in, I swear, as well as breakdowns and lots of portfolio shots so that people can see what type of assets are in. There's still a ton of work on our end. It's just we have GDC coming up, so we have to release this in its current state. And there should be more improvements to the project over time as well, more sounds, probably more interactivity, and we
And
will most likely fix issues as well.
and maybe FPS, who knows?
Oh yeah, we are thinking about doing a FPS mode, so you're not stuck within VR. Because I know that a lot of people don't have a VR device. At the end of our development cycle, we will probably have that as well. You will be able to choose between FPS and VR mode.
Yeah. Well, and also, by the way, I'll give two quick shout outs on that front. First of all, for anyone who doesn't know, even if you are in a project that's made for VR, if you go into your world settings and you come out of VR game mode and just use the vanilla game mode that Unreal Engine comes with, and then don't click VR preview, just click regular play, you are now, able to fly around the same way you're able to
Yep.
move around in the editor. You don't have the interactivity, but it does give you a way to at least engage with the scene. Another thing you can play with is if you drop the Meta XR plugin into this. I don't have this set up right now, but I could use the Meta XR simulator. Yeah, it doesn't know where to point to it. But even without a VR device, I could use the Meta XR simulator and actually move around with the hands and grab objects and do all of that entirely from within the editor. So that's quite nice as well.
And one last thing, if you are in production, if you work in the game industry and you are interested in, having custom props or anything, like vehicles or having a cool team that does cool work, make sure to contact us. We'd be happy to work with you guys.
Yeah. And sorry, guys, there's one more thing I wanted to demonstrate and show as well. One more thing you get with the Meta XR tools, even if you're not going to use Steam VR, this is still even if you're not going to use a Meta headset, even if you're only in Steam VR and all you have is a Valve Index, I really like that Meta gives you this Meta XR project setup tool, and it actually gives you some different recommendations for optimizing your project for, PC Link. And I already asked you guys this, but I didn't get an answer. So now I'm going to put some pressure on and ask it to you in front of our audience, which is why don't we have instant stereo on in this project?
That's a very good question. I have no idea.
Oh, no worries. I just wanted to check because certainly I think we'll get a performance gain with it.
Yes, I remember why I removed it. It's like it's only rendering one eye and reprojects on the other, right?
Oh, for some of the materials or something like that?
Yes, I ended up having like a flickering shadow on one eye, so that's why I
Oh,
disabled
that's
it.
why.
There we go.
Oh, okay.
That
Yeah,
makes
yeah, exactly.
But here's a nice little pro tip that I forget about all the time, but I'm glad the Meta plugin tool catches it. If you don't plan on baking anything, if you uncheck enable static lighting, it makes it so you literally can't bake anything, and you actually get some performance back in the project, because it now, it kind of has that mental space freed up where it's like this project will never be baked, and then some of those resources can go back toward all the great Lumen and Nanite stuff. So anyway, good little tool that I recommend anyone start with. You don't actually specifically need to be targeting these particular headsets. It's more just general VR optimizations. Cool. Okay. we're ending on some good professorial notes, but thanks so much again, Anthony, Greg. What an incredible gift to the community. I think you very easily could have thrown this up on Gumroad or anywhere else and charged $200 for it, and it still would have been worth it. There's so much here to dig into. And I think there's going to be a lot of people who are going to be able to look back on their VR careers. Some people who are probably students who are just getting started now, and they're going to say, hey, I remember when I downloaded this really cool project from Sentient Art, and I was off to the races making my dream project, my dream game, my dream architecture visualization. And I think you just have a lot to be proud of here. So thanks so much.
Thanks a lot, Alex. And I just want people to make cool stuff and explore. That's all that I'd like here. I could have been rich, but I decided not to.
Well, anyone at GDC, please buy these guys a beer. Show them how grateful you are for this amazing project. I know if they're ever in New York City, I'm gonna take them up to the top of the World Trade Center or something, and I don't know, say this is all yours. I'll say something that will express my gratitude here. But yeah, again, guys, what a pleasure. Thanks for giving me a sneak preview of this earlier this week, and glad I was able to help out in my own small little way. And I hope we just keep a dialogue going about all your work and anything that happens with this. And I hope all of our audience keeps an eye on the GitHub and continues to play with this awesome project.
Thanks. You, and see you soon, guys. And don't hesitate. If you want to talk to us, just reach out by email or directly on our socials. We'll be happy to help.